The first learning outcome is very simple. Just number one, it's a state that one, so all we need to do is to state what it says. So number one, a wave transfers energy. Nice easy one to get started. Learning outcome two is explain the difference between a transverse and a longitudinal wave. So this is the one that we were looking at yesterday. And what we had, remember, just at the end of class yesterday, it was about this idea of what happens to the medium, what happens to the particles which are actually moving to create the wave. And for the transverse wave, first of all, so if we define that. So these are new technical words, so watch the spelling of them when you're first coming across them. Right, transverse. And we discussed yesterday that you kind of quite often end up using your hands when you're trying to describe these. So a diagram can help make life a lot easier. So a transverse wave is a kind of traditional wave that looks something like that. And the key idea, right, if I use some different colours, is if you were a particle sitting on that wave at that point there, you would oscillate up and down while the wave transfers energy from left to right. Okay? So we'll put a formal definition in a second, but the green arrow there is the direction of energy transfer, because we've just said waves transfer energy. And the red arrow is the oscillation or vibration or disturbance, any of these words would do, of the medium. Right? The medium is whatever it is that's vibrating that creates the wave. And then the words that we'll put with that the oscillation of the medium is that, do you prefer right angles or 90 degrees? You're all quite happy with the phrase right angles meaning 90 degrees? You could write either if you were answering the question. Is it right angles to the direction of energy transfer? Okay, so that's our transverse wave. And I'll start a new screen for longitudinal. You're busy still copying that one probably. Okay, for a longitudinal wave, so a more difficult word I would say, right? So longitudinal, longitudinal. Right? You met latitude and longitude. Have you done geography? Have you met that yet? Okay, so it's based on that same sort of word. And once again, we're going to go with a diagram, but these waves are a wee bit more difficult. And what you get is usually shown kind of that way. So see these lines, they're kind of close together at some bits and spread out at other bits. And if we put on our arrow for the oscillation of the medium, so if I picked one of these, I'll use a ruler this time. I should have used a ruler last time. And it never stays in place. Oops. So oscillation of the medium and then over the top of it, so literally over the top of it, direction of energy transfer. So this wave is moving left to right, and the individual particles of the medium are also oscillating backwards and forwards, left to right. So remember, they would never actually travel from the left-hand side to the right-hand side. So the bit of the slinky you were holding the other day didn't make its way down to the far end of the slinky. So for longitudinal waves, the oscillation of the medium is parallel to the direction of energy transfer. And then learning outcome 3 is to give examples. And it's actually quite straightforward. There is really just one example of longitudinal waves, sound. Right? The seismic waves are kind of that strange one that they can have a mixture of both transverse and longitudinal. So we'll avoid them as an example. And then pretty much every other wave that we'll meet is a transverse wave. So the main ones, water waves, light, they're probably the two most important ones. Later on we'll meet the whole electromagnetic spectrum, which are all linked to light as well.